Alrighty, here's the study guide for Unit 5. Just a little fill in the blank. An inequality is a mathematical sentence. Okay, so we are going to draw a shaded arrow to the blank of a point on the number line to indicate that every number greater than this point is the solution. So we need to go to the right on the number line because that's where our numbers get larger and greater. Draw a what kind of circle around a point on the number line to indicate that the point is a solution to the inequality. We need a closed one, guys. Remember, because that means it's definitely a solution. Versus the open is like, oh, maybe kind of, not really. All right, to graph the inequality x is greater than 2, you draw an open circle and then draw a shaded arrow to the right. Remember, follow the yellow brick road as long as that variable is on the left. Okay. A blank consists of two statements joined by the word and is only true when both statements are, okay, so a compound inequality, but more specifically, it's a union. Remember where they go together? So it's true when both statements are true, or when they crisscross, or however you want to say that. A blank consists of two statements. Okay. Oh, sorry, this is not union, guys. My bad. Oops. Intersection. Sorry, it's where they intersect. Sorry, this one's a union. And once again, it's another compound inequality. Two statements by or, and it's true when either or statement is true. So either one of them is true. And I'm not going to even write that because I think y'all know it. All right. The graph of an inequality in two variables is the set of all points in the coordinate plane that represent all of the possible solutions of that inequality. For linear inequalities, use a blank boundary line when the inequality contains, okay, so remember, if it's got that equal sign under there, it's going to be a solid. And the second that it doesn't, it's a dashed. All right? All right, so let's go ahead and move on to the actual math set of definitions. All you have to know for this one, it says which inequality represents all real numbers greater than, so we want a greater than sign, so there's a greater than, there's a greater than, there's a greater than, and there's a greater than. And so that's now out because that's an or, so that's off. And less than or equal to, okay? Less than or equal to. Wait, did I mess this up? I think when I was kind of messing. Okay, well, it's less than or equal to. Ultimately, I changed some of these guys. That's my bad. But it should be 4 is less than x, which is greater than or equal to 7. That's what it should look like. I'm not sure which one that is on there. That's my prod. Next one. The solution x equals 0 satisfies the compound inequality, true or false. All right, all you got to do is plug in. And remember, when you plug in, you use parentheses. So the first one is negative 2x. It's greater than or equal to 6. So we're going to plug in 0. Okay, so that's 0. That is a false statement. So that is not true for this one. However, this is an or. So if it's an or, remember either or could be true. So we got to try out this other one. So 2x plus 1 is greater than 5. So we want to go ahead and plug in that 0. That's 0 plus 1. That is also false. Remember, the alligator wants to eat the bigger number. So then if both of them are false, that one's false. Now, if this would have said and, they would have to had been true for both. Okay, so or one of them at least has to be true, and both of them needs to be true. Hint, hint for the test. right, so let's solve and graph some compounds. So compounds, we go ahead and break them up. And the other one will be, so we're going to subtract 1. Divide by -2. Remember when we divide or multiply by negative, we flip our inequality. And then I want my variable on the left, so I got to flip it again. Over here, I subtract 1. Divide by -2. Flip it because I divided by a negative. There's my other one. So on the number line, actually, let's do, what is it? X, so I go to 3. It's a closed circle. I'm going to the left. X is open circle going to the right. Now I need to determine, remember this is a less than, so thans are ands. So this is an and. So remember, and is where they intersect. Therefore, I go back and I do my solution. It's on 0, it's on 3. It's an open circle on 0, it's a closed circle on 3, and it's just their intersection. Okay? All right, so let's start with this one. So I multiply by the reciprocal, which is 4 over 1, which is just straight up 4. So x is greater than 8. Or divide by 5, x is less than 3. All right, so let's graph. So ors are unions, remember. All right, so I go to 8, open circle going to the right. I go to 3, open circle going to the left. This is or, which means either or could be true. So lucky for me, I'm done. I'll have to draw another one. All right, next one. Split it up. All right, we start by dividing by 9. And then remember I need my variable on the left. So I got to flip it again. There's my first solution. Over here, divide by 9. All right, let's graph it. All right, -3, open, going to the left. -6, open, going to the right. And now we go back and we see, okay, what are they asking us? This is a gray tor, right? Gray tor. So this is an or, which means either or is true. And since they're both going, both ways, my solution is all real numbers. So I would shade in that entire line. Over here, let's go ahead, subtract 1. Subtract 6. Okay. Oops, -1, -2, -3. All right, so if I go to 2, and it's a closed circle, going to the right. -2, open circle, going to the left. And then I need an or. So either or is true. So once again, done. All right. Which ordered pair is not a solution? So yes, you could solve for y, and you could graph it and then see if it's in the shaded area. But honestly, guys, just go ahead and use these points and plug them in. Honestly, that's the easiest way. So here's my equation or my inequality. So let's plug it in. So -1 plus 5. My y is negative 3. That's supposedly less than 15. All right, so this is negative 1 minus 15. It's negative 16. The alligator is eating the bigger number. 15 is greater than negative 16, so that's true. So that's not going to be a winner. Let's try with B. So negative 1 plus 5 times a positive 3 is supposedly less than 15. So this would be 14. Okay, once again, that is true. So that is a solution, so that's not going to be one that we do. Let's go to the point 13. Okay, 15 is not greater than 16. That is false. So that is not a solution, so I'm going to circle it. Just to make sure, let's try out 3, 2. And once again, that's true. So, oops, that is a solution. Okay? Oops, why not? These look way more difficult than they are. Remember, anytime we're graphing, y'all, we're using y equals mx plus b. Now, I know this is an inequality, so we're actually going to have to make this equal an inequality. But let's start off with, we start off by finding our b. So our b is our y-intercept, which is right there at negative 1. So let's put a y and an x. Our slope is rise over run. So here's a good point. So rise over run. So I'm falling 2, going to the right 2. So that's a negative 1 slope. So just negative x. If you want to put the 1 there, it's not wrong. And then it's a solid line. So if it's a solid line, it needs to have that equal sign under there. And if you look, the shading is going down. So this is a less than. So y is less than or equal to negative x minus 1. All right, let's go over here. Same thing. So I start with my b. It's at negative 1. Put your x, put your y. Now I need to find my slope, which I like that point. So I go up 1 over 1. So 1 over 1 is just 1. So I'm not going to put anything this time. Once again, this shading is going downwards. Therefore, it's going to be a less than, and it's a solid line. So put your equal sign. Friendly reminder, guys. Let's say we take this exact same problem, but we made it dashed. And instead of it being shaded over there, it's shaded up here. We would still have this minus 1. We would still have this x, and obviously that y. But we would not have an equal sign under there because it's dashed. And if my values are getting larger, it's a greater than. So just be careful on if it's dashed, and then if the values are getting larger or less. All right, first of all, can you use 0, 0 as a test point when graphing, blah, blah, blah? Explain. So let's go ahead and put it into y equals, because that's how we, or y whatever, because that's how we graph. So I'm going to start by immediately flipping this, because I want the y on the other side. So I've got to flip that inequality. If it's eating the 2x, it needs to eat the 2x. Now I would divide both sides by negative 5. When you divide by or multiply by negative, you flip your inequality. So my equation, when I go to graph it, is this. And that's a direct variation because this is a plus 0. So my y-intercept is 0. I fall 2, run 5, then I do the opposite. It would be dashed. So when it comes to deciding about shading, we can't use the point 0, 0 because that's on the line. So no, we can't use it because it's on the line. That's not a test point. So I always tell y'all to use 1, 1. Technically, you could use whatever one you wanted. If you wanted to, you know, be crazy and use negative 5 as your test point, you know, it's your life. You're living it. But I wouldn't. But 1, 1's pretty easy. So I would plug in 1 here. Anything times 1 is that number. That's the identity property of multiplication. This is true, right? True statement. So we would shade where that problem is or where that point is.